one of 4 of the most attractive, witty, charming co-hosts on probably the best podcast you can ever watch or listen to.
Okay, hello everyone. I have got some audio on my slides. If it doesn't work, don't worry, we will roll with it. Quick question. We got any gamers in the room? Any gamers? A few gamers? Sort of like? Yes, gamers. I used to be a big gamer, a huge gamer. And there is something that just brings out a huge sense of nostalgia, the way gaming should be. This is the way gaming should be. Sonic the Hedgehog, that's what gaming should be, isn't it? Yes. The good old days. And how Sonic works is you start off in the green hill zone. Here he goes, he's running, he's collecting rings, he's jumping around, he's having a great time. Sonic was epic. And then you get to the end of level boss, and you had to defeat Dr. Robotnik. No one knows why he had this machine with this big ball. It was just the way things were. But eventually, Sonic would defeat him. He would then fly off, and for no known reason, there are rabbits and chicks inside some kind of rocket thing. And our goal appeared to be to save these rabbits. We then got our rings added up, we got points. Epic days, right? Epic days. I'm 45 now. Right? Who's playing this when they're 45? You gamers, tut, tut, tut. Still playing games at 45? Maybe you're older, who knows? No, I don't play Sonic the Hedgehog anymore. It's much better. Oh, hang on. Before we talk about that, there were all these zones in Sonic, wasn't there? Do you remember? The Green Hill Zone, the Marble Zone, all these 6 zones we'd go through. But I said, I'm 45. I don't play Sonic anymore. I'm playing games. I've got kids. There are much better games to play. Excel. That's right. Not just Excel, spilling the spreadsheet. This is a game baked directly into Excel. This is spilling. He is a spreadsheet. And in the next 30 minutes or so, we are going to complete spilling the spreadsheet. Okay? And by doing this, we are going to answer... Oh, no, we're going to do this across 6 zones. We're going to start with the dynamic ranges zone. Then, oh, look at... So you start off spilling. You see he's here. He's a bit tentative. He's a bit nervous. Hello, I'm spilling. He then gets a bit more bold and brave. Here he is. A bit more avant-garde. The scalar lifting zone is where it gets hard. So he's a bit tired. He's not quite sure. He's feeling a bit lethargic. Now, in the next zone, yeah, he's wearing a disguise, okay? See if you can spot him. Yeah, he's got a wig on. Look at that wig. See? And the next one, he thinks he's Bruno Mars. He's wearing a hat. And finally, the double spilling zone is where things get really hard. So these are the 6 zones of spilling the spreadsheet that we are going to work through today. And in doing so, we are going to answer the question, which functions spill? And we're going to start, obviously, in the dynamic ranges zone, which is Act 1. If we want to complete the dynamic ranges zone, we need to know a certain piece of information. First of all, we need to understand what a range function is. A range function is any function that returns a range as a value. These are the range functions. We have if, x, lookup, offset, choose. You can read. I don't need to read them all. These are the functions that if we provide a range as an argument, it will return a range as a value. So, let's go take a look. Here we are in our dynamic ranges zone. There's spilling. He's there just in the corner. We're going to start with the offset function. So equals offset. Now let's suggest we just select that first cell. We want to offset by 0 rows, 0 columns. We'll close that. Calculate. It returns 52, right? No one's surprised by that. Offset, 0 rows, 0 columns. It returns 52. But it doesn't really return 52. Because if we use the cell function and the address, and then lose your offset, which I'll do again. It doesn't return 52, it tells you the cell is C5. So what happens? Offset calculates, it goes, hey, that's values in C5, and then it tells you what the value in C5 is. This means offset is actually giving us a range and not just an underlying value. Now, if we wanted a specific height, we could go for 6 rows, 1 column. We'll close that and calculate. And look at that, offset spills because it creates a range. This is no different than just selecting those cells and doing that. That's what offset is doing, but as a function. It is returning a range, not just the underlying values. But in zone 1, we can go even further because we can have dynamic range references. Any range reference can be replaced with a range function. Let's suggest we have C5 to C10. We can replace C10 with a range function. Here we'll have an XLOOKUP equals XLOOKUP. My lookup value is the 30th of June. I will select those cells, return my values. Haven't got a lookup value. Equals XLOOKUP. Opening brackets. How slow can my man go? I know you're all excited about this now. You've never seen XLOOKUP before. This might be the highlight. It returns 93. Okay, so 93, no surprise there. But it doesn't return 93. It returns C10, and then C10 equals 93. How do we know? If we use the cell function and the address, it tells us it returns C10, which means if we want to spill, we could say, hey, start there. I want to go to the XLOOKUP of however far we go, and that now creates a dynamic range. So that is the end of our first zone. In our first zone, we saw that range functions spill because they create range references and work just like if we were to reference any range. I know, you guys, that you really want to know one thing. What about our score, our time bonus, and our spill bonus? 190. Good work, everyone. Here we go. Look at that. The points add up. Fantastic. 190 points. That is a fantastic start with a dynamic ranges zone. Which brings us on to act number 2, the basic array zone. Now, in most computer games, it starts easy and then it gets a little bit harder. The truth is, the basic array zone is the easiest zone we could attempt. And that's because if we use a basic array function, they spill by themselves because that's all they know, that's what they do, that's what they're programmed to do. And these are the kind of functions, when we think about basic array functions, they just spill because they do. So let's head back into our basic array zone. There's spilling, he's a bit braver there. Examples are unique. So if we use the unique function, we can select, let's say, our region. I'll close that. Try and stop a unique function from spilling. You can't stop it. The basic array functions will spill by themselves. Let's have another look with filter. Want to filter, let's say those values there, where our region is equal to east. Again, filter spills, you can't really stop it. Now, I know that was disappointing for Zone 2. You're expecting something more exciting, but there's nothing more exciting to say about Zone 2. Basic array functions spill because they do. But even with this basic level of knowledge, we still get points. Look at this. Let's add those points up. Fantastic, 340 points. Good work, everyone. We then come on to Zone 3. Anyone in my masterclass yesterday will know all about the scalar lifting zone. The scalar lifting zone. This is where spilling starts to feel a little bit tired because it gets a little bit tricky. Basically, functions have 2 kinds of values. So the arguments inside a function are either single values or they are multiple values. So a single value is a piece of a number, a piece of text, a true or false. If it's multiple values, it could be a range or an array, and they might be two-dimensional in a matrix or one-dimensional in a vector. And if we understand the arguments in any of our functions, we can force scalar lifting. Here, we have our XLOOKUP function. We have our lookup value. Excel expects a single value. Our lookup array and return array, Excel expects multiple values. So our understanding of the different arguments in functions is important. Because if we have an argument which expects a single value, we get scalar lifting. So a scalar argument is just one which expects a single value. So any function where you have an argument that expects a single value, we get lifting, spilling, by providing multiple values into that argument. So let's go take a look. We're now in our scalar lifting zone. We're going to have another XLOOKUP. And we're going to look up the value alpha from our table, from our column. We're going to return it our value. We're going to close that and calculate. It returns 72. It's no surprise. The 72 is there. Our lookup value was a single value. So it was just cell G4. Now, that lookup value is, Excel expects a single value. But if we provide multiple values into there, we get spilling. We now get both of those cells returned. So, by using scalar lifting and using that on an argument which expects a single value, we get a spill range. But it goes further. That's just if we've got one. Imagine if we had multiple scalar arguments where we provide multiple values. I know that's a lot of multiples, so imagine you've got a function where they've got arguments, where two of those arguments only expect a single value, and in both of those, we provide multiple values. Let's go take a look. We're going to use sum ifs as an example. Sum ifs. Our sum range will be our values. We want to sum where our item is equal to alpha, and let's say where our region is equal to south. In that argument, the criteria that we have there of G8 and H8 are our scalar values. Excel expects to have a single value. When we calculate that, it gives us the value of alpha and south. And it returns 135, which is the values from our table. Now what happens if we expand alpha, so it's then picks up two values? Well, here we just have standard lifting because we have an argument which expects a single value and we provide two. So if we calculate that in that scenario, we're looking up alpha and south, which returns 135, but also bravo and south, which returns 94. If we expand our second scalar argument, what's going to happen? When we calculate, Excel pairs up these items. It goes, hey, I'm with it. Your first item in each array, I'm going to pair those together. So you're going to sum if alpha and south, and also bravo and east. And that is pairwise lifting, where we provide multiple values, where we have arguments that expect single values, and we provide multiple values into those. Now there's an issue. There's a challenge that we have to encounter, and that is the array of arrays problem. If you look at the definition of the array of arrays problem and the definition of pairwise lifting, you'll notice in both scenarios they occur where multiple scalar arguments are provided with multiple values in a range or an array. That means that in any scenario, we might get pairwise lifting, our formula might calculate correctly, or we might get the array of arrays problem. Let's go take a look. Now, I apologize in advance for what I'm about to do. It's an assault on myself, my own character. I know that some of you are going to feel filthy after this session. You're going to have to take a shower, but I'm sorry, we are going to use VLOOKUP to illustrate this point. So we have a lookup value, we have a lookup. We're going to look up the value of alpha from our entire table. We're going to return from column 4, and we want a false to get an exact match. Unsurprisingly, that's 72. There's our alpha, there's our 72, and it's column 4. Now we know if we expand that down, we're going to get, so that's now alpha from column 4 is 72, delta from column 4 is 72, delta from column 4 is 80. So you'd think that if we say, hey, I want alpha from column 4 and delta from column 3, well, that should give us is 72 and small. They are the values that we would expect if Excel applies its own principles of pairwise lifting. But it doesn't work. Look at that. 72 and 80. It's as if this other thing no longer existed. Hey, I'm going to ignore that 3. I just don't care very much. So that is the array of arrays problem. And we don't know, before we look at how a function works and what it does, we don't know whether we're going to get pairwise lifting or the array of arrays problem. If we have pairwise lifting, it works on the relative position, everything works. If we get the array of arrays problem, it doesn't work. And we don't know which functions they are and which functions they aren't. We just have to test them and work it out. So that brings us to the end of the scalar lifting zone. Functions with arguments that expect single values spill via lifting because we provide multiple values. That was a tough zone, people. Tough zone. Let's have a look at the points. Only 160? What? That's criminal. We should be getting more than that, I tell you. But we'll add them up. 500 points. We're halfway through. I wonder if we'll get to 1,000. I just don't know. But that then brings us to our next zone, which is the forced lifting zone. Act 4 is the forced lifting zone. This is where there's spilling. He's wearing a disguise. Shh, don't tell anyone. He's got his wig on. So before Excel 2007, there was an add-in called the Analysis Toolpack. Anyone remember the Analysis Toolpack? Yep, some of you. In there, you could install that and you had additional functions. And they would give you additional functions into Excel. In 2007, those functions became natively available inside Excel. However, they have a problem in the fact that they accept multi-value arrays, but not multi-value ranges. So they accept multi-value arrays, but not multi-value ranges. Now, there are loads of functions in here, but the most common ones are EO month, EDate, quotient, is even, bin to dec, workday, week num. There's loads more. There are loads and loads more. But all of these have this issue around spilling. So let's go take a look. Let's suggest I want to create some month-end dates with the 1st of January, but I want the 31st of January and then the 28th of February. So I want 6 month-end dates with my start date of the 1st of January. I'm going to use the EO month function. My start date is the 1st of January. For my months, I'm going to use sequence. We want one row. Have I spelled sequence right? I haven't got my glass on, I can't tell. One row. Let's go to 6 periods. I can ignore the start and stop. And that calculates, actually, we do want to start. Let's start from 0. So I want 1, start from 0. There we go. That now gives us our 6 months from January to June. That is spilling out from that cell. Now, we know that, just based on how Excel works, we can use helper cells and helper things. So rather than using the sequence function, why can't I just reference a range that already has the numbers 1 to 6? That should work, right? That's how Excel works. That's what Excel's meant to do. And unfortunately, when we calculate that, we get the dreaded hash value error. Why is there a hash value error? Like, there's no hint there. Even if you click on this thing, help on this error. Oh, that might give me something. Go here, error in value. Anyway, sometimes it pops up and goes, hey, I think you might want to include a little apostrophe before that. Have you left out a bracket? No, I haven't, Excel. It's you. You don't know how these functions work. So EO month doesn't accept a multi-value range, but if we convert this range to an array, it will work. So how do we convert it to an array? We perform a calculation on every cell in that range. Therefore, we could use minus minus. That would make each of those numbers minus, and then minus those numbers again. That would then make it work. We could multiply by 1. That would work. We could add 0. That would work. Let's try that. And it now works. So we forced our range into an array, and now our function works. So anytime we are using anything that uses a function inside the analysis toolpack, we need to force that function to spill by converting the range into an array. So we use force lifting to cause it to spill. Good work, everyone. 190 points this time. That's more like it. Yeah, give yourselves an applause. You're doing really well at spilling the spreadsheet. I know for many of you, this is the first time you've played this game. We then move on to the non-spiller zone. The non-spiller zone. And again, we're back with this concept of single values and multi-values. If we think about the sum function, sum has arguments which expect multiple values. Number 1, we can provide multiple values into there, the number 2 argument, and so on. And this is where we have the non-spiller zone. And we have to use special functions to cause the non-spiller functions to spill. And these might be known as the lambda helper functions, such as reduce, by row, map, pivot by col, make array, all those functions that came out a few years ago. So let's take a look. Let's suggest that we want to sum each of the rows in our table, and we want that to spill. If we just use sum, I could select a row, close that, and calculate. That now gives me a single row. If I want this to spill, you might go, hey, well, I don't want to do that, that's for sure. If I want that to spill, I just drag that down, right? And just as we saw with scalar values, it's going to spill. Of course it doesn't, because sum expects multiple values. That's what sum does. So instead, we need to use one of these lambda helper functions. We're going to start with our sum. We're going to say, I want you to sum each row. So we want to sum each row from our range that we're going to select. I'm going to have to kill PowerPoint. Give me a second. We want to sum each row. Now, Excel doesn't know what row is. Okay, I've just made this up. Sum each row. I could have made up any name I like. Excel doesn't know what this is. So we use the lambda function. We tell Excel, I've just invented something called row. And Excel now goes, I get it. You've invented something called row. Fantastic. I now know what row is. It's something that you've invented. And that's when we use these iterator or lambda helper functions. We can use by row on our array. And now, our by row function breaks our array up into separate rows, and therefore we can then spill. So, in this non-spilling zone, we can use these lambda helper functions. Now, I know many of you were dissatisfied with my use of VLOOKUP earlier. So let's solve that, shall we? Let's make sure VLOOKUP gets its day in the sun. We can bring back VLOOKUP away from this array of arrays problem. And we can use a function like map. So map is also a lambda helper function. We're going to take our first argument. We're going to call that lookup value. We'll take our colnum argument and call that colnum. We could call these anything we like. Now, these names don't exist. I've just made these up. So if we press return on this, Excel would give us an error. It'd be like, I don't know what you're talking about. What's lookup value? What's colnum? Therefore, we use our lambda function of lookup value and colnum. We've now created those names. So Excel goes, I'm with it. Lookup val and colnum are things that you've invented. I'm with it now, I understand. We then have to pass in the values into this function, and we're going to use map for that. Our first range is alpha. Our second range is our colnum. And when we come to the end, we should close. When that calculates, it now gives us the 72 and the small, which is what we should have had all along. So anytime we have these array of array issues, we can go to the non-spiller zone. That is the iterator function. So functions with arguments that expect multiple values spill via the lambda helper functions. Set our points. We've done well. Yeah, applaud yourself. I think you deserve it. Oh, we're close to that 1,000, aren't we? Are we going to do any good in that last zone? And the last zone is the double spiller zone. Yes, it is as dangerous as it sounds. The double spiller zone. Let's suggest we have a table and we want to get all the items which have the name of alpha. That's easy. We can use the filter function. And the filter function is a function that spills. You can't stop it. It will spill by itself. And it will go, ha, I've spilled. But, I don't know why I made that up just then. That was a bad mistake. But what happens if we want to spill our filter? We want to spill our spill. I wish I had a word cloud this year that said the number of times I've said spill. It would probably equal the number of squirrels from last year. But let's suggest we then wanted to achieve this kind of scenario. Well, we need to spill the spiller. We need to double spill the spill. And to do that, this is what we do. We start with our first filter of alpha. We then stack that result. We take our second result of Bravo. We then stack that result. We take the next result of Charlie. We stack that result. And then we take the next one of Delta and we stack that result. And we use this, we achieve this with the drop reduce lambda stack combo. Easy to remember, people, easy to remember. If you want to complete spilling the spreadsheet, you need to master this combo. So let's take a look. Here we are, we have our filter function. We're already looking up alpha. Now, you might think, well, why can't we just select the full range? That should work, right? And when we do, it doesn't work because the include argument isn't a scalar argument. So it expects multiple values. So this is what we're going to do. We're going to lose my mouse again. I'll come back to PowerPoint. We're now back. Are you ready for this? We're going to use reduce. I know you're excited about using reduce. The people yesterday in the masterclass, they're all over reduce. They're like, this is easy peasy. We know how this works. We've got reduce. And we're going to loop, we're going to have our initial value, which is going to be an empty text string. We then have our array argument, and we want to loop over each item that we have. Next, we want our function. We're going to use our lambda function, which has got two arguments, the previous value and the current value. Then we're going to hstack our previous and the filter of our current. If anyone sees a typo, let me know. When we calculate, it's going to spill that out, but not quite as we wanted it. And that's because we had to start with this kind of initial value of double blank, and we've got these NA errors. So let's clear those. We use a drop. We want to drop our first column. We then want to if error our NAs. In that scenario, we want an empty text string. And there you go. We've now spilled our spiller. We've now spilled our spiller. Congratulations, everyone, for achieving that zone. So, double spiller zone, functions which already spill can spill again via the drop reduce lambda stack combination. So, I know there's a couple of questions that are left outstanding. A few questions that we haven't yet answered. So which functions spill? It is entirely dependent on the arguments in that function. If they have single values, we can make them spill. If we have multiple values, we can make them spill. Therefore, I'm going to boldly say, with 3% of confidence, that we can spill all functions if we understand how they're constructed and what the arguments do. That's the answer to the first question. The second question is arguably more important, and one that we haven't really touched on. The second question is, have we done enough to rescue the rabbits? And I think we should find out, don't you? Here's Spilling. Come on, Spilling, let's cheer him on. Come on, Spilling. Come on, Spilling, here we go. Yay! He's defeated Dr. Robotnik. Look at this. Come on, Spilling. And out come the rabbits! Let's now come to our points. Oh, yes, look at that. Fantastic. Good work, everyone. Give yourself a round of applause. You have completed Zone 6 of Spilling the Spreadsheet. So thank you very much. He's been Spilling. I've been Mark. If you want a free course about modern Excel formulas, there's a QR code. Thank you very much.